On the second part of the demo, we will use another model. As you can see in this model, we have only one source, and we have this meshed system with multiple transmission lines. So basically two rings, and one transmission line is considered here the protected object by those very same two SEL311L relays. So at first, let's start again with the simple case, a fault with very small impedance at 50% of this line. Let me compile. Now the model is loaded, we can start the simulation, and we're going to use the very same interface. So we connect the relays to the relays with the serial communication. We then change access level and pass the command to close the breaker here. Now the same for the second one. So now let me just set that feedback from the fault. I'll set it here once more. Rising edge 50%. Prepare the trigger. And this time I'll start with the fault on phase A to ground. We can see that only the relay on bay number 1, or the relay closer to the source, operated. We can read some information from the relay, from both of them. As we can see here, the relay downstream, or relay on bay 2, didn't see any type of fault. Of course, we can see that given that the breaker is still closed, but on relay upstream, we can see that it recognized a fault between phase A and ground, so 1001, and it's saying here zone 2 or level 2. So that is what it understood giving this specific fault. So let's clear the fault. Issue the command to close. And now let's do a fault between phases A and B. Let me just trigger my capture. Fault between phases A and B. Okay, both relays tripped. Let's read a little bit. So relay on bay 1 saw fault between phases A and B as expected, and understood that this fault was now inside zone 1, which it is the case since the fault is at 50%. Relay number 2 understood the very same, so they're operating in sync. We can see here on our capture that the relays had some delay between themselves in terms of operation. One operated before than the other. So this is at this point here is the time that they sent the command to the breaker to trip, but only right here is when in fact those breakers opened. So again, we can add one cursor here. So the first relay opened with 0.085 milliseconds. The second one did the tripping at 0.093 seconds. Okay, clear the fault, close breakers. I'll reset the targets. Let's do one more. This time phase A to phase B and ground. Both of them tripped. Let's read some information from the relay. So now they understood also that the fault is AB and ground. That's correct. And also understood that the fault is within zone 1. Again, we have the capture here that shows how the relays operated. The first relay effectively tripped its breaker at 0.09 milliseconds or 9 milliseconds, and the last relay tripped at something like 92 milliseconds. I'm using all the wrong units, forgive me about that. Okay, and just to finalize this case, we could try the one more fault. Let's clear the fault, close the breakers, set the trigger. I'll also reset the targets, and I'll cause the 3-phase short circuit. Again, this is how they behave. Let's read something from the relay. Understood the 3-phase fault as expected, and it's also within zone 1. So okay, it looks good. When we tried one phase to ground, we saw a little bit different behavior, with one breaker that couldn't open or didn't want to open, while the other understood a fault at zone 2 or level 2. Now let's move to another option here of study. Let's keep the fault at the same place, but instead of using 1 or 0.1 ohm, let's make it 2 ohms, so kind of a higher impedance fault. And let's compile. Okay, loading the model. So again, the very same process. Start the simulation and let's connect to the relays. Trigger our capture there, set our capture, and let's start again with the one phase to ground. Okay, seems like a similar behavior. As for the low impedance fault, let's read a little bit. So the fault was recognized properly by the relay number 1. Relay number 2, we actually see the last fault before this one, so we didn't clear the target. It basically means that it didn't see the fault again, and it also understands that this fault was on number 2 for or zone or level 2 for relaying on bay 1. Okay, clear fault. Close breaker. Let's reset the target. Good. Set the trigger and cause a short circuit between phases A and B. So now we saw that relay 2 opened its breaker, and then after some time we saw that relay 1 also opened its breaker, but the time for operation of those two was quite long, and we can see here on our capture that with a 2 seconds interval we didn't see any of the relays opening. So it took a bit more than 2 seconds for the relay on bay 2 and a few more milliseconds for the relay on bay 1. Let's read a little bit from the relay. So we see that it was not identified in neither of these zones, zone 1 and 3. Let's read some other information here. Yep. So we would have to go and check all the registers to see exactly why it's tripped, but we understand that it couldn't recognize it inside this any of the zones or levels of protection. Some other protection tripped. Let's check this row. Yeah, here we have instantaneous phase time. It's actually phase time over current on 51 PR is 1. So I think both relays actually operated on the 51 PR, which would explain the longer time to trip. Okay, let's clear the fault, close the breaker, close the breaker. Let's reset the target, set the trip, and now phase A and B to ground. So if you guys noticed here on the breakers here, we saw that bay 1 opened first, and we can actually see here on the capture that happened, and then relay on bay 2 took a little longer to trip given the same fault. So let's read a bit from the relay. Okay, so the relay on bay 1 understood that it was a fault AB to ground. That's correct, and it understood that it was a fault of level 2 or within zone 2. It could explain why it actually operated faster than relay on bay 2 at this time, but relay number 2 recognized the precise fault, AB and ground, but it didn't recognize the zones. So I think in this case it might have tripped once more on that. Let's see here. Yep, this is clear. I think it tripped also on the 51 PR. So again, phase time over current. If I'm checking this descriptions correct. Good. Proceeding. So let's just do the last fault of this example. So let's close the breaker, close this other breaker, trigger the capture, and let's do the 3-phase short circuit. Yep. Again, a little bit more than 2 seconds to trip. Let's read from the relays. So, yep. So we can already see here that relay on bay 2 operated on 51 PR. Check here, we see identified the proper fault. Same with relay on bay 1, proper fault, level or zone 2. And if we check the 28, yeah, 51 PR also there. Okay, let's go to one other scenario. So back to the model. Let's reduce the impedance once more. Oops. And I'll put the fault at 0.95, which means much closer to the breaker on bay 2. Let's compile. Okay, let's start the simulation and connect to the relays. Commands to close, reset target. Let's start with the fault on same sequence. We observe once more a similar pattern there. Only relay on bay 1 operated. Corrected identification of the fault, and also we have the zone 2 or level 2 high. And for breaker on bay 2, nothing. Okay, no fault. Let's close this breaker, reset, set the trigger here, and short circuit between phases A and B. Both relay operated. So now in this case we can see that the fault was recognized properly between phases A and B. Then we see that relay on bay 1 identified the fault on zone 2, while relay on bay 2 identified the very same fault, phases A and B, but for this relay, this fault was within zone 1, which makes sense. That's where the fault is, at 95% of the line that is outside of zone 1 reach for the relay on bay 1, but is well inside the zone 1 reach of the relay on bay 2. We can see here the operation around 8 what is that? I'm again confusing my units here, but let's put this so this is the first strip right there. So that's our 84 milliseconds, but relay on bay 1 operating with a zone 2, I actually took almost 570 milliseconds to trip. Okay, let's clear this fault. Give command to close the breakers. Reset target. Set our capture. And then do AB to ground. Let's issue some command to read. Oops, didn't read everything. Yeah. So once more, a similar pattern. So relay number 1 operated around 90 milliseconds, 94. Actually, relay number 2 operated with 94 milliseconds, while relay number 1, bay 1, operated with 150 milliseconds. approximately. Clear the fault, reset the targets, give command to close, and set the trigger and the last fault for this scenario. Okay. So both relays identified the three-phase fault. Once more, relay on bay 1 identified fault on zone 2, and relay on bay 2 identified it on zone 1. If we check the timings here, once more, relay on bay 2 is around 86 milliseconds, while relay on bay 1 operated around 490 milliseconds. Good. And there is one last scenario that I'd like to show, and in this case we're going to remove this internal fault of this transmission line and actually apply it right here. So I'll enable the fault and I'll put it as at 95%, which means that it will be really close to our Bethlehem bus. So let me connect the ground here and compile. Okay, in this case, right before I start my simulation, I'll just have to update this widget and change this this handler here for our fault component. Now my transmission line is named transmission line section 4, and also here on my signals I have to get once more the proper trigger signal. So let me set it here, digital, this one, and let's go back to those 50%. Set the trigger, start the simulation, same process, connect to the relays, and apply the first fault, phase A to ground. Still a similar behavior when we read the information here from the relays. Of course, relay on bay 2 didn't see anything. Relay on bay 1 saw the proper fault and identified it as zone 2 or level 2 here. Here's the capture. So if we check the current that we measured from the fault, if we open one of the breakers, then the fault on the other breaker, basically the other breaker can't read the current that is supplied by the fault 2, because the fault is external to the line being protected. So this does make sense. Let me clear this. And fault between phases A and B, and now none of them opened, so we applied the fault, but nothing happened. If we check what the relays saw, we'll see that not much. Okay, so I will clear the fault. Relays are still there. Let's reset the targets, set the trigger, and do phase A, B to ground. Now we have only the relay on bay 1 operating. Yep, the same behavior on the current, that is clear. And if we check the time, for the tripping of relay on bay 1, it was around 230 milliseconds. So let's read what it saw. So it says here phase between A and B and ground, and identified it as zone 2. Okay, let's clear the fault, close this breaker, reset the target, and set the trigger and cause our last short circuit. And once more, for this 3-phase fault, none of the relays actually saw that fault, so they didn't operate. So I think this is the demo that we had prepared, and I hope that this was good enough to show possibilities, and this is just the beginning of what you can do and observe when using relays connected to a real-time simulation platform like the one from HIL. Thank you.